Hey everyone, a very happy Tuesday and welcome back to our Arm Tech Talk series. This is the place for the latest and greatest in trends, technologies, and best practices from Arm and our partners in our ecosystem. It's great to have you here today, and I'm really excited to be back. We had a couple of weeks off for TinyML Summit. Hope you managed to get there, and great to see if you managed to pop by the Arm booth and some of our partners' booths. And then we had a couple of weeks off for Easter, so I hope you had a good break if you took any time off. And indeed, if you celebrated Easter at all, hope you had a good Easter. So we're back. We've got a bunch of tech talks coming up, and I'm really, really excited today, in particular for today's tech talk, to have Jeff Rogers, Vice President of Sales and Marketing from Sensory, talking about a really exciting work that they've done with our Cortex-M55 and Ethos U55, and in general, showing you some really exciting stuff around AI and natural speech language recognition on these devices. So before we get to the content today, we do have a couple of little housekeeping slides that I usually go through. If you've joined one of these before, you know the drill, but I just want to go through them in case you're new and want to find out a bit more. So Jeff, if we can go to the next slide, that would be great. And I'll just tell folks how they can get involved with the conversation today. So in addition to using the Q&A box in the Zoom menu bar at the bottom, which is where you can ask me and Jeff all of the questions you want about today's topic, though probably Jeff will be best placed to answer them. As it's him giving the talk, I can answer a couple of them, I'm sure, but it'll be mostly for Jeff. You can also tweet us using the hashtag #ArmTechTalks or share it on LinkedIn or any social media channel you wish. All of the tech talks we've done in the past, this is a weekly series. In the past, it used to be every 2 weeks focused on AI. We've now done them weekly, focused on a bunch of topics. And you can view all of those on demand at youtube.com/arm. There's a tech talk playlist with 60 plus videos on there, and they're all timestamped, so you can all scroll across to find the content you want at the time you want. So do check those out. And if you like what you see today and you want to get more of the latest trends, technologies, and best practices from Arm and our ecosystem, head to arm.com/tech talks and you can register for all of our upcoming sessions. And I want to give you a sneak peek at some of them now, actually. So, Jeff, let's have a look at the next slide. And there's a little table where all the talks are displayed for you. So we've got, as I mentioned today, a really exciting talk and demo from Sensory. So we'll come on to that in a second. And then we've got talks from Renesas, DSP Concepts, and BrainChip over the next few weeks. So they're at the same time, 4 p.m. UK, 8 a.m. Pacific. So wherever you're joining us from, hope you can join those next few talks. They're on arm.com/tech talks, and you can just register and very quickly get the links you need to. So let's talk about today's topic. Today, we are joined by Sensory, and I'm really excited for them to talk about what they've been doing, their technology, their solutions on Arm, and how they are working and doing some incredible stuff with the M55 and U55 chip from Aleph. So Jeff's just going to flag over a slide with a fantastic little mugshot of you. You're joining us from a hotel in the Silicon Valley area. So thank you so much for joining today, Jeff. I'm now going to hand over to you for you to take it away with today's presentation. And audience, please get your questions into Jeff as the presentation and demo continue. So Jeff, thank you so much for joining. It's great you could join us. Take it away, please, with today's Tech Talk.
Thanks so much, Tobias. It's great to be here. As Tobias mentioned, I'm actually on the road, and as would have it, I've come down with a cold. So I'm going to do this with just to show that our technology is also health independent. So even though I'm got a cold and my voice is a little scratchy, the recognition should still be perfect, of course. Yes, it's great to be here with Arm. We're close partners with Arm. We run across many of their different platforms, from M4s to 7s to the M33s, and of course we're talking about the M55, U55 today and what we've done there. I've been at Sensory from the beginning, so a lot of years experience in designing speech technologies and computer vision into consumer products across the board, and it's been an interesting ride. We've pivoted several times as a company. We're definitely known as the kings of on-device. So the question is, who is Sensory and who's using our technologies? We've licensed more than 200 companies around the world. We're designed into more than 3 billion products. I love those numbers. 3 billion products really shows that we've been at this a long time. We know what we're doing. The technology is well proven. It's well tested in the market. It's well accepted in the market. Every company logo you see there on the right side are real customers. They've designed real products using our technologies, into a variety of different markets. You can see that we span markets from general consumer electronics, PC, mobile wearables, cameras, to AR, VR gaming, home IoT appliance, automotive, fintech, enterprise, medical, and healthcare. And you can see the again the logos there. Again, these are companies that have done real products with that have shipped in quantities, not little lab demos, not just concepts, but real products. And so again, it's a real testament to the technology that we've developed and where we're able to take it. Now, I mentioned that we've always kind of been known as the kings of on-device, and that's definitely the case. But we've also expanded into a cloud solution as well. And with all the talk about ChatGPT as an example, this also can fit nicely in here because we can run local wake words and local command sets, and then we can take advantage of things like ChatGPT and our speech to text and other in the cloud. But today we're going to focus on what we've done on the M55 U55. And so we created a little project and we came up with these goals. And so the first goal was, well, we got to run on the ARM M55 U55 and really take advantage of both of those within that core. Secondly was we want to make it easy. Any vocabulary, any language, any size, no data collection required. So typically, particularly when you talk about on-device technologies and solutions, there's a tremendous amount of data that you have to collect, a lot of processing and development and tuning, and so we said, well, let's make a really lofty goal here, and let's try and make this super easy for developers and companies to work with. Secondly, is that we want to make it efficient, so we want to take advantage of TensorFlow and TensorFlow-Lite acceleration, design the architecture to really best take advantage of the U55 and the M55. And then we asked ourselves, can we use the Helium functions to reduce wake word current consumption? That was part of this project. And then lastly is, let's make it super accurate, of course. I mean, it's one thing to get something running on a platform. It's another to have it actually work with real people in the real world. And that's definitely been something that we've seen over and over and over again. Some companies that I talk to say, oh, yeah, doing a wake word is easy. I can just use open source. I can do it myself. And those things are true. You can use open source. A lot of times you can do it yourself now. But the question is, once you get to the real product with real people using it in real world environments, in the car, outside, on the train, wherever, and then across a variety of accents, that's where it can get really tricky. And that's, again, where our focus has been is, okay, we want to keep it really accurate, but it still has to be very small. It has to be very efficient and, again, easy to use. So this was the project goals. So then kind of talking about the requirements and what we did. So number one, again, is to make it run on ARM. So did that. We ported our TrulyNatural SDK to the M55 U55. So Sensory's got 3 different embedded technologies or solutions that we license today. Truly Hands-Free, we're definitely well known for that. So Truly Hands-Free is primarily wake words and simple command and control. So there's a good chance for those that are listening to this presentation have probably used Sensory in products. If you've spoken to Samsung products, to LG products, to Spotify, to GoPro, to Garmin, to Zoom, to Motorola, to the list goes on and on and on. Those are all great examples of Truly Hands-Free. TrulyNatural is our large vocabulary on-device recognizer. So by large, it can be tens of thousands of words, and natural language means I can just talk to it as I'm talking to you right now. I don't have to just, it's not like answer call, reject call. That would be a great example of Truly Hands-Free and more command and control, as opposed to TrulyNatural, again, allowing the person just to speak to a product in a natural way. But again, without touching the cloud. So that's the goal. That's the requirement for this one. And then we also have our Truly Secure, which is also on device. And this provides speaker verification and computer vision technology. So these are used today in things like tablets and phones, and banking applications use these technologies today. So for this project, we said, let's take our TrulyNatural, which traditionally has been a larger model, a larger engine, and let's get this running on the M55 U55. So then we met with Aleph at an ARM conference. I think it was last year, the middle, I guess probably August of last year. and met them and understood that they were one of the first chips or one of the early chips to be using this new ARM core. And so we said, okay, let's work with the Aleph guys. Let's run this on their assembled E3. And what I'm going to show you today is an actual live demo, which is always interesting and scary for a webinar like this, but running on their AI ML app kit. And it's really cool. It's a nice little board. It's got a display. And so it was like, okay, let's put all these pieces together and get that running. So from a sales and marketing perspective, that sounds easy. From an engineering perspective, there's a few things we had to go through. Okay, so making it easy is one of the goals. Well, we want to make it compatible with our VoiceHub. And I'm guessing that a lot of people on this, listening to me, have seen or heard about our VoiceHub. But if not, I'll show a quick demo at the end of what VoiceHub is. But basically, VoiceHub allows you, the developer, to create your own custom wake words, your own custom command sets, and your own natural language grammars using our TrulyNatural. So it's a very easy tool to use, and it removes all the need for data and sensory getting involved. It's a very popular tool today. More than 1,000 companies and developers are using it today. And again, I'll show you a quick demo of that, of how it works. Okay, make it efficient. So we want to take advantage of the ARM accelerators and the TensorFlow Lite and the TensorFlow Micro, and really kind of explore different approaches. You know, should we run everything here or everything here? And later in my presentation, I'll kind of show you how we broke things up to have the most efficient solution we could. And then, of course, make it accurate. So taking a large language model and scaling it down takes some tricky effort. But then I guess the goal, the requirement is that even once you've done that, it still has to be accurate. So you're by making something much smaller, you're giving up things that the technology can utilize to perform speech recognition. And so it took kind of a handcrafted custom approach to take advantage of the N55 U55 so that we don't give up accuracy. And later in my presentation, I'll show you some comparisons that are pretty spectacular. Where you can see, hey, we went from something really big to something much smaller. Okay, let's see. So the next thing we did is we developed a statistical language model using VoiceHub. So VoiceHub will allow you to create what I call a simple grammar, where basically you just type in everything that you might want to recognize. And again, later in my presentation, I'll show you a demonstration of this. It's quite fantastic. It's very easy to use again, and it allows you to create, again, wake words in this natural language. So then the next step is take that grammar and create a statistical language model. A statistical language model, or an SLM, is where you look at that, you take that grammar and you say, okay, if I hear this word, there's an X probability that this word's going to follow, and then there's a Y probability that this word's going to follow. And so by creating a language model, you can actually add additional performance, recognition accuracy performance, because there's some statistical modeling built into this thing, as opposed to I can say any of these things in any order that I want. And so you can see here we created an acoustic model that's 946 kbyte. And it's amazing that I'm talking about kilobytes in today's world. Language model 920 kbyte, and then the technology code's less than 400 kbyte. So it's very, very small. And then you can see some of the example phrases: open door and cook popcorn, etc. So there's a real microwave oven in the market today from Farberware that's using our TrulyNatural, but it's using a much larger recognition set because we're running on a much bigger chip. And this was something that came out a couple of years ago. So it's you know, the language model in this case, I think it's 15 megabytes or something. So you can see we took something really large and we made it much smaller. So here I want to share a quick demo of this microwave oven that's in the market today. In fact, I have one in my house. It was kind of a funny story. When we were using it to collect data, I had this big ugly Wi-Fi antenna, and my wife hated it. And as soon as we were done, she says, "I'll get that out of here." And within a few days, she said, and my daughter as well, "Hey, can we get that microwave back? It's easier to use because you can just talk to it." Let me show you a quick video of how this one works.
Sensory's TrulyNatural embedded speech recognition and natural language platform improves the ease of use and feature accessibility in consumer products. This domain-specific assistant allows natural language voice controls on small appliances, such as a microwave, without requiring an internet connection. No confusing setup and no risk of lost privacy. Sensory's TrulyNatural.
Voice Genie, open door.
Open door.
Voice Genie, cook for 1 minute and 10 seconds.
Start cooking 1 minute and 10 seconds.
Voice Genie, pause.
Pause.
Voice Genie, resume.
Continue.
Voice Genie, add 37 seconds.
Add 37 seconds.
Voice Genie, stop cooking.
Stop cooking.
Voice Genie, open door.
Open the door.
Voice Genie, cook for 90 seconds.
Start cooking 1 minute and 30 seconds.
Voice Genie, heat for 1 minute and 30 seconds.
Start cooking 1 minute and 30 seconds.
Voice Genie, start 1.5 minutes.
Start cooking 1 minute and 30 seconds.
Voice Genie, large popcorn.
Popcorn 3.2 ounces.
Melt 1 stick of butter.
Melt butter 4 ounces.
Voice Genie, cook salmon.
Fish.
Cook 3 potatoes.
3 potatoes.
Cook soup.
Soup.
Reheat my pizza.
Pizza reheat.
Soften ice cream.
Soften ice cream 8 ounces.
Frozen broccoli.
Frozen vegetable.
Defrost 2 pounds of chicken.
Defrost 32 ounces.
Voice Genie, set the clock to 3:15.
Set clock to 3:15.
Voice Genie, set a timer for 5 minutes and 20 seconds.
Set the timer for 5 minutes and 20 seconds.
Voice Genie, what can you do?
Basic function.
So really cool product. As I mentioned, it's on the market today. And let me just go to the next
Including-
slide here. Actually, I'll go back to this one here. So what you saw there are several things. Number one is you saw natural language. So you could say cook for 1.5 minutes. You could say cook for 1 minute and 30 seconds. Cook for 90 seconds. Cook, start, heat, whatever. So again, it's natural language. And the beauty of this product is you basically buy the product, bring it home, plug it into the outlet, and start talking to it. There's no connect to your Wi-Fi, there's no app, there's no skill, there's no, you have to go through all the process of connecting to a cloud engine to do these things. And probably one of the most exciting features, which is really, really simple from our perspective, is the open door command. I don't know why, but to most consumers, it's magical to say open door and the door automatically opens. That's like the thing that everyone loves the most. So great product. And as I mentioned, what you saw there was it was I think 15 or 20 megabyte language model, and it has a vocabulary of about 64,000 words. Now, you think, why would I need 64,000 words in a microwave? Well, you don't, but we've also built in a really nice garbage model where we can recognize other things and say, no, that has nothing to do with the microwave oven. So if you go through and you look at the accuracy and compare what we're doing on device to a cloud solution, you can see that our task completion rate, or the TCR, is significantly higher than the cloud-based solution. And there's a very specific reason for that is we've designed in this case, a language model that's very specific for a microwave. Whereas if you go to a cloud engine, it's typically a general purpose assistant. And so giving it some commands can be confusing because they're trying to recognize everything as opposed to something that's very task specific. And so, again, what we did is we said, let's take this microwave oven model, and now let's get this running down on this new M55U55 platform. So 2 different approaches. One is we looked at, we could run everything on the M55. So again, there's the audio, there's the feature extractor, there's the acoustic model. This is the sensory neural net in here, the language model decoder, the NLU processing, and then the result. We can run all that on the M55. However, to make it more efficient, we said, let's take the acoustic model, really the neural net side of things, and take advantage of the Ethos U55. And by breaking that up, you can see here the results of that. So on the top, I've got my baseline. This is all running across the CM55. And you can see that the total CM55 MCPs is 276. Obviously, we're 0 for the U55 because we're not using it in this case. And then you've got the TNL, which is TrulyNatural neural net at 205. And then again, not utilizing the U55 in this baseline. And then the TrulyNatural is 74% utilization. So then you look down at, we looked at two different approaches. The TensorFlow Lite micro, which is doing an 8x8, and then the TensorFlow micro 2D 8x16. So this is a convolutional 2D 8x16. And if you look at those numbers, the conclusions are pretty awesome. So if we're running again the taking advantage of the neural net on the U55, it's 15 times faster than running on the CM55. So you can see that 13.5 as opposed to 206. And the hybrid approach is pretty awesome because you can see that it's 330% faster overall recognition. So 81 as opposed to 276. So really that taking advantage of the complete architecture that ARM has created in this new core is fantastic. And again, just looking at this chart here, you can see where taking advantage of that and breaking out that hybrid approach here, where again we're moving the TensorFlow Lite down here to the U55. So the other comparison is accuracy. So it doesn't matter if it can be really small and really efficient if it stinks in recognition accuracy. So what are we giving up by doing that? So the conclusion here is not much. And you can see that the convolutional 2D 8x16 at 10.5 word error rate is very close to the 10.3. And again, word error rate is a standard kind of approach that a lot of people use for measuring speech recognition accuracy. And the beauty of what we've done here, combining with our own NLU, is that even if I miss a word somewhere along the way, the natural language understanding can take it and say, oh, this is what you really meant. And so even though you might miss a word here and there, with the NLU, you get the task completion. That's really what matters, is that task completion. So again, you can see here that by taking advantage of this hardware, we can still have an extremely high recognition results. So we then said, okay, now we need a platform to run this on, test it all out. And as I mentioned, we met Aleph at this ARM conference. And so we said, okay, let's use their Ensemble E3 chip, and let's take that same microwave oven model, but let's add a few things to it. Let's add a wake word, because I want this thing to be hands-free. Let's add a voice activity detector, or a VAD, so that it knows when I'm done speaking and I don't have to push buttons, obviously. Let's add our NLU. Let's add the LCD output, and then let's add live audio recording as opposed to feeding in batch by batch recordings. So there's two different options in this chip, which are pretty cool. There's the high performance core, and then there's the high efficiency core. And again, you can pick which one is required based on the task that the task that you're trying to accomplish here. You can see our peak RAM is actually less than 1 MB, and the total flash for everything. So you've got the acoustic model, you've got the language model, you've got the wake word, the VAD, the NLU, the display, the blah, blah, blah. That whole thing is less than 2 megabytes, which is pretty awesome. So let me stop sharing this for a second and show you a live demo here. Okay, and switch to this camera here. Okay, so this is the Aleph board, and hopefully you can see this okay. It's just on this little table that I've got sitting here. And so it's on and listening right now. And so I can just say the wake word, and then I can say a couple commands, like, for example, I can say, voice genie, add 30 seconds. And the green is what's been recognized, and the yellow is the NLU result. So you can see the two kind of combined together. Voice genie, open door. And super fast, as I speak it, this thing's recognizing, it's awesome. And even with my scratchy voice, and actually this board is, it's more than arm's length away from me. Voice genie, cook my broccoli. Voice genie, defrost 1 pound of ground beef. So short things like open door, long things like defrost 1 pound of ground beef, and you have no problem. Voice genie, cook my popcorn. Now, something else that we did is we built into this also a background model or a garbage model, so that we can say, hey, these are the things that you're trying to recognize, but people might say other things, or in the chance that the wake word has a false fire and then it goes to something else, we don't have the cloud connection here to say, oh, that's not intended for me. And so we had to build all that into this solution. So as an example, I'm in San Jose right now, and I could say, Voice Genie, what's the temperature in San Jose? So you can see it recognized it, but the NLU says there's no command. So the NLU is smart enough to say, okay, yeah, that doesn't make sense for a microwave oven. So in this case, this demo's got, I don't know if it's 15 or 20,000 words that it recognizes, but it's a significant model that's running here. And the whole thing, again, is running directly on the SAL chip. And very small, very efficient, and as you can see, extremely fast. Basically, as I'm speaking it, it's recognizing, giving me the result. There's no lag time. Certainly, and again, the beauty of a solution like this is I don't have to go to the cloud and then have the do all this connection with the cloud and back. Okay, so let me go back to my other camera here and share my screen again. Okay. So the conclusions from our project is deep learned TensorFlow end-to-end approaches they definitely have some challenges. So collecting a lot of amounts of data, expanding language coverage is expensive and challenging. And so again, the idea is, well, let's use VoiceHub to make this a lot easier. Secondly, is compared to equivalent model running solely on the M55, the hybrid approach runs significantly faster without any significant accuracy loss. Obviously, the lowest power consumption is achievable by revalidation for accuracy. So I can run something very, very small and then run a larger model on the application processor as an example, or go to the cloud where we can revalidate in the cloud as well. And then finally, compared to an end-to-end neural net that would run entirely on the E55, the hybrid approach requires less data to train, distributes the load over both of those processors, and then obviously allows for potential parallel processing and dynamic vocabularies, that sort of thing. So that was the conclusions from our project. The goals, and then the conclusions, which are, again, were pretty exciting to us to see how it all worked out in the end. So lastly, I wanted to introduce you to our VoiceHub. This is an online portal. It's free, so there's no cost to have access to this. Here, again, you can create your own custom wake words, phrase spotted command sets, natural language grammars, a lot of different languages, a lot of different Arm core platforms that are supported in there. And again, the idea is build quick, test quick, download, and go from there. So let me pop out of this and go to this here. Okay, so what you're seeing on the screen is the VoiceHub tool, and this is an example of a wake word that I want to create. And so here I name the project whatever I want to. So I'm going to call this one Hey Sensory is my wake word. Then here I can select the language, and you can see that there's a lot of different languages that are offered in VoiceHub. I'll stick with US English, obviously, but you can see that there's Australian English and Indian English and UK English and US English for kids, which is pretty fantastic. Lots of different Frenches, Asian languages, and more. Then you can select the SDK version if you're running on a Sensory SDK. In this case, we'd be running directly on the smaller platform, and we support a lot of different platforms here. So you can see there's that's the SDK version. Here's the output format. So right now I'm just going to run this on my mobile phone. So over here, what you're seeing is my mobile phone on the right side of the screen. So I can just do some quick testing as an example. But you can see that there's a lot of different platforms here, many different Arm platforms that are supported here. And then I can select the size that I want, and you can see that I can go as small as 80 bytes and as large as 1 megabyte. And then basically I just type in the wake word that I want. And so I've just typed in Hey Sensory is the wake word. There's this little speaker icon over here that basically is a TTS engine that plays back what the recognizer is expecting to hear based on what you typed in. So if you typed in something that phonetically would be said differently than it's spelled, you can catch that before you actually build it and say, oh, no, I really meant this. So as I press this, you should hear Hit playback.
Hey Sensory.
Okay, got it. That, yep, that sounds like what I'm expecting. So then I build it, and in this case, I've already built it. It usually takes about 45 to 60 minutes to build a wake word, because what it's doing is there's no data. Again, there's no recording, so it's all synthetic data, and it's building a model that performs well, taking looking at false accepts and false rejects. So, I don't want to just be talking and the things I said something, that the wake word, and false reject is when I actually say it, nothing happens. So it's already built. Then I can download it. Okay, download the model. And then I can download it, and then I can run it on a board like the Alpha board directly, or using my phone. I come over here and I scan the QR code. This is great. I just scan it in there, and now it's running directly on my phone. So here's the model that was created in VoiceHub, and now it's over here on my phone. You see the green lines bouncing. It represents that the microphone's on and listening. So I can just say, hey, Sensory, and this is going to say, yep, I got it. That's the wake word. And again, has a nice balance between false accept and false reject. And even if I say, hey, Sensory, in the middle of the sentence like this, I still want it to pull it out. And so it's a true always-on listening wake word, which is fantastic. Just to show you a quick example of a larger project, I didn't have the microwave one handy, so I'm using this one. It's a barista demo that we've created. And here again, I name it, I choose the language, the format that I want, the sizes that I want. So this is a 512 kbyte with a background model. So again, I've got that garbage model built in. And then I can select a wake word that I've already created. So in this case, it's a Voice Genie wake word. So within TrulyNatural, I then I create the intents that I want. So in this case, it's ordering beverages. I select the slots, or I create the slots that I want. So, there's beverage, and there's a number of shots, and there's order and size and sugar, and whatever I want to do. And then down below, I create the grammar that I want, and it's all drag and drop at this point. So I just grab my beverage one. So somebody can say, coffee, or somebody can say single shot coffee, or large coffee, or single shot large coffee, or large single shot coffee, or I want a coffee, or I want a single shot coffee. So again, building out and making it as dynamic or as complete as you want. So it can be very small, or it can be a much larger, more complex. It's totally up to the developer. And this is all part of VoiceHub, which again you can access from our website. Okay, so let me go back to the presentation here. Okay. So thanks very much for attending. It was great to kind of show you the project that we went through, the development steps, the goals that we had established for ourselves, and then special thanks to Ala for providing the chip that we could run on in the demo, and really put the whole thing together and say, okay, from start to finish, here's the project. Let's do the testing. Let's see it running on the real hardware. Thank you very much.
Jeff, that was awesome. Thank you so much. What a great tech talk. That's the perfect combination, even with a cold, right? I want one of those microwaves. I mean, that worked brilliantly. You've got a great demo that worked even with a slightly croaky throat. And as you said, that pays testament to the quality of the solution, but also not being able to understand the commands, but the intent, what you're saying, the acting on it, it just is just great. So really, really great tech talk. And some good questions are already coming in. I've got a couple of questions I'd love to ask, and then we've got a good amount of time for Q&A. So please do get your questions in, audience. And as you say, great tech talk, great demo on the Aleph Silicon. So really, really great. I think you mentioned about the cost of let's start with the VoiceHub tool that's going to work ourselves back. I think you mentioned that the cost of the VoiceHub tool, or rather lack of it, but just to share again for the audience who may have missed it, what's the cost of VoiceHub, and where can they actually get it from? Do you have a link to it that you could paste in the chat at all, or?
Yeah, so if you just go to sensory.com website, and under resources, just select resources, and you'll see VoiceHub right there. And then there's a big giant button that says request access. You just hit that, fill in your information, and typically within 24 hours, you'll have access to VoiceHub. VoiceHub, again, will support the languages that you saw, the different platforms that you saw, It will also provide you access to Truly hands-free for the wake words, for the phrase spotted commands, which I didn't demonstrate, and also TrulyNatural. And there is no cost to VoiceHub. And the goal there again was, it used to be, for the first 26 years of my life at Sensory, when companies would say, hey, Jeff, I want to develop a wake word, I want to develop this recognition set, we'd say, okay, send us the information. We'll give you a quote. It's going to take, X number of weeks or months, and it's going to cost this. And, and then it was like, well, okay, people are kind of trying to use something we already had. Now let's make it easier. Let's actually use the real commands that you want. And so again, that's how we developed VoiceHub to really kind of replace that need for, faking it or trying to use something else and saying, hey, just imagine that when you say play music, you're actually opening the door. That's just silly. And VoiceHub solves that.
Awesome. No, thank you so much, Jeff. So yeah, do head to the website, do request access and try it out. And, I know we've talked about some of the ARM platforms, and obviously you've talked about the Cortex-M55, Ethos U55 here today with the demo, but what other ARM platforms can you run on?
Yeah, it's a good question. So I mentioned some of these, and I'm going off memory now because there's a lot of them. We've been tight partners with ARM for a lot of years. So M4, M7, M33, M55, obviously the M55, U55, the whole A series, any of the larger microcontrollers, those can actually run our more advanced technologies, such as our truly secure speaker verification and our computer vision technologies. So from really small to large, we run across the board.
Awesome. Yeah, I was going to ask about Cortex-A, so you've covered that nicely. So that's great to hear. That's fantastic. And one of the other things is, I'm sure people on this call as well, right? If you look at there's obviously a real advantage, as we've seen, to running offline and running embedded and on all these commands. But are you able to support maybe a kind of hybrid solution that could take advantage of the cloud as well as this kind of edge software as well?
Yeah, it's a great question. I touched on it briefly at the beginning of my presentation. So last year we introduced our Sensory Cloud. Before that, we would always say, oh, the cloud is evil, the cloud is bad, the cloud is, you sacrifice privacy, don't go to the cloud. And then we developed Sensory Cloud. We said, oh, the cloud's wonderful, the cloud's amazing, the cloud is okay, as long as it's a private cloud. And so the Sensory Cloud provides speech to text, text to speech, computer vision, speaker verification. These are all part of our Sensory Cloud, and we've developed it as a Dockerized container so that our customers can either run on the Sensory Cloud, which is we're SOC 2 certified, so it's very private, very set, ready to go, or we can provide the container. They run everything on their own cloud. Now, the beauty of that approach is, now if I do want speech to text as an example, that gets tricky on device. Now, that said, we are a member of SOFI. And we are able to run speech to text on the SOFI platform today. So we have a SOFI board. We're running full on speech to text on that, which is pretty exciting. And again, thanks to ARM for that one. But we can also do speech to text on the cloud solution. And so now you can take advantage of things like ChatGPT. So I've got a really cool demo. Anyone that's interested, just reach out to me directly. Happy to arrange a time to show you what we're doing with ChatGPT and kind of taking advantage of that prompt engineering where I can say, you are whatever, type in a couple of prompts, and then I just speak to it using our speech to text. And wake word that runs local on the ARM, of course, is where everything starts.
Awesome. Thank you so much, Jeff. Great answer. And, I think we'll jump to some of the audience questions. So do keep them coming in. And we've got plenty of time to ask, to grill Jeff, as it were, with your call. Yeah. Hopefully you'll be able to answer as many of these as you can. And obviously we can take some offline if not. So George has asked, what was the most difficult part of creating the application here? Was it training the ML model, developing the firmware with TensorFlow like Micro, or something else? What was the, we always love to hear the kind of challenges involved here, right? And how you overcame them. Would you be able to share any of those from what you worked on with the team and the engineering team on this?
Yeah, it's a good question, George. We've already worked with the TensorFlow Lite approach for some other platforms and kind of thinking through, okay, how can we take advantage of that? I think the tricky part was getting everything shrunk down and really being able to therefore take advantage of splitting this hybrid approach between the M55 and the U55, and getting those pieces together. It took several, well, I'd say it took a couple months of engineering effort to get there and be able to kind of divide. Okay, we're going to run this here. We're going to run these things over here. We've looked at a couple other neural net accelerators, and it's a very different approach for us. Typically, we designed our technology not to have to utilize those because we wanted to run on device before these things came along. And so now that they've come along, we've altered kind of some of the algorithm approaches to take advantage of those things. So I think, and again, I'm not the engineer that did the development project here, but I think that probably one of the more difficult things was, okay, how do we take these larger models, get them compressed down to take advantage of the neural net accelerators, and yet not give up recognition accuracy, and also not have the response time, become, milliseconds as opposed to milliseconds, which is where we are today.
No, exactly. Thank you for that, Jeff. And actually, someone else, Oliver's just asked about how difficult it was to reduce the size of the networks, and you kind of already alluded to that. Is there anything else you wanted to add specifically on that question?
We've always been focused on device running, and so from the beginning, everything was really small. In fact, we started Sensory as we were called Sensory Circuits, and we started as a little chip company. We had our own little 8-bit microcontroller that was kind of like a Z80 in architecture and an 8051 instruction set. And back then, we had 2K of RAM and 64K bytes of ROM, or maybe there's one. Yeah, I think it was 64K bytes of ROM. And then we added these hardware accelerators. This is back in the 90s. This is before DSPs. And I remember demoing back then. I would say, okay, let me show you a demonstration. Wait, everyone stop talking. And then I would have to check the room acoustics, make sure there wasn't echoes, and hopefully I didn't have a cold, and blah 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 blah. Obviously we're a long ways from there, but from those very humble beginnings, we started with everything had to run very, very small. So as we transitioned from a silicon company to an IP company, we had that background of everything has to be small, as opposed to the normal approach that a lot of companies use in our space is you start in a server, you start in a cloud, or you start on a really powerful processor, and then try and figure out how to get small. We started small and then expanded up. And so having that history has really helped us, and it's really helped us run across a lot of different, as I mentioned, a lot of different ARM platforms.
Amazing. Thank you so much, Jeff. No, it's a great bit of story, a great bit of history as well. I always love kind of hearing the backstory of this and the companies involved. So no, thank you so much for that. And we've had a question. I don't know if you've got any further information, and actually it's escaped my memory about when the Aleph semiconductor dev board with this is going to be available, and is it available now? I'm not sure. I think it might be best to contact Henrik on that, but I don't know if you can recall from your discussions with the Aleph team on that.
It's a good question, and I don't want to quote things for them because I don't know exactly, but I know that we got the board, and I think the boards are available. And now that the technology is ported, it runs on those boards, and I believe they're going to be showing it here starting now. What we haven't done as yet is we haven't added the support in VoiceHub directly yet. So we kind of cheated because we're internal, and we said, okay, I got the internal tools to VoiceHub. Let's use that. Let's create those. Let's create that model that runs on there. What we haven't done as of today is actually integrate that directly into VoiceHub. So that's another step that has to be done.
Awesome. So yeah, absolutely more to come. And I think racking my brains, I think they might be available to be ordered soon via a distributor soon, maybe Arrow or other folks like that. So yeah, just have a look. If you're in doubt, definitely contact Aleph and get in touch with them, because the board's capabilities are great. And as you say, there's a lot available, and they can try a lot of stuff already. So that, which is great. So they're really excited about that. A question that's come in around how exactly do you deal with acoustic models in different languages? Do you develop individual models yourself for each language? That's coming from June.
Yeah, it's a good question. So as you saw in VoiceHub, there's a lot of different languages that are available there. Those are language models that we've developed ourselves. So a kind of a generic language model for all of those languages. So a couple comments on that. Number one, we can develop wake words and command sets without having the full language model. So as an example, I have several customers in Vietnam. We don't have a Vietnamese language model today, but I can still develop it just by some additional data and some additional hand tuning, which obviously means therefore that it's not included in VoiceHub because VoiceHub requires that basic language model. So across all the languages that are supported today, yes, we have generic language models available that allows me to just type in the word. So if I choose Japanese as an example, I'm typing in the Japanese characters. I don't force people to Romanize it. It's and the same with Korean, same with Mandarin. You're typing in with those characters you're creating specifically for that model. One of the other questions that I've had in the past is, can you run two languages at the same time? Yes, you can. So in VoiceHub, you can create a for example, I've got a demo where it's running two different wake words and then two different command sets. And the two wake words, one is Japanese and one is Mandarin, and then the command sets, one is Korean and one is US English as an example. So within an application, you can definitely mix languages together. VoiceHub has not been designed to hybrid or mix those models together, but you could certainly do that at the application layer.
Thank you so much, Jeff, for that. And just going back to the previous question, I'm just going to paste the link shortly to what I believe is the Arrow link for the Aleph board if folks are interested in giving that an order and trying stuff out. So we'll definitely do that. But no, thank you so much for that answer. And Oliver's coming to ask about the kind of ecosystem, the ARM ecosystem, and how it's really helped and your ability to create a full solution, and also how easy it was to integrate the ARM ethos NPU when you got a spec with just the CPU. So can you talk a bit about kind of how the ecosystem has affected and enabled your ability to create that full solution from the ARM angle and the ARM ethos as well?
Sure. So as I mentioned, we've worked and partnered with ARM for many, many years. And as ARM is the leading IP to core supplier out there, we said, okay, let's tie ourselves in closely here. Let's figure out what we can do together. And let's start on their, working on their different platforms. So starting from, M4s and all the way up to the A series as an example. So having that ecosystem allows our customers a great deal of flexibility because they can say, hey, I'm using this ARM core. Great, we already support it. Check it off. Okay, what's next? The second part of your question was how hard was it? I think the second part of the question was how hard was it to move take advantage of the neural net accelerators on the ethos. It took a little bit of effort to get there. It was several weeks of development and some back and forth. And then the other part was, okay, we could do all this in simulation, but now I want to do it on a real chip. And that's the second part of the challenge that always occurs. Simulation is one thing. Doing it on real hardware is kind of another step. And so again, that's where we appreciate Aleph for providing their support and their board to say, okay, here's a chip that's using these two cores. Now go from simulation to actually running on here and having the audio path work and having everything just move together. Took another several weeks of development to get there. Now that it's done, having different variations of that's going to be a lot easier, and the core technology is ported. So that means that any of the languages that we already support, those are instantly supported on there as well. Particularly once we add it to VoiceHub to allow developers directly to create.
Awesome, thank you so much, Jeff. And then we've got a final question, kind of more sort of commercial angle. You may have to take this one offline, but any insight you can give about from Roman here about VoiceHub being free, but can you give me information about the royalty, subscription fee, or other costs to put it on a device / chip?
Yeah, it's a good question. So VoiceHub's free. It's used to, the purpose of VoiceHub is to allow developers to create products. And something that I hadn't mentioned, but I will now, is we have primarily people use VoiceHub for development, for prototyping. Yep, these are the commands I want. This is the grammar that I want, the wake word that I want. And then when they go to actual production, they'll often switch to hand-tuned models because a hand-tuned model will always outperform something that hasn't been touched by anyone at Sensory, and that's obviously the beauty of VoiceHub. However, we have a few customers that have developed with VoiceHub, did their testing, and said, you know what, VoiceHub is great. I don't need the hand-tuned model. So we have some customers actually going to market with with VoiceHub created models, which is pretty exciting and interesting. As far as the cost, our business model is one typically of per unit royalty or a SaaS model. So VoiceHub is free, as I mentioned, and so typically we will then have a license fee and then a per unit, or more and more popular today, or more of a SaaS model where someone's developing an application, as an example, or they're developing a product that has a monthly subscription, and we just become part of that monthly subscription. And those numbers really depend on what we're talking about, quantities and commitment and other things. So definitely reach out to me directly on those, and we can talk about those in more detail.
Absolutely. Yes, please do reach out to Jeff and grill him with all your questions. But no, really appreciate it. Thank you. And thank you for all your questions. And we're just about coming up to time now. But Jeff, is there anything else you'd like to add before we close out today?
Yeah, I guess the call to action here is check out VoiceHub. Connect with us directly. Love to talk in more detail. Sensory's been around a long time. As you saw from my presentation, a lot of big companies that we work with. But I'm also interested in the smaller companies and the startups as well. We were a startup once ourselves, and there's a lot of interesting new ideas that are coming out, both from the very established companies to the startups as well. So interested in talking through those. I've got a sales team all over the world, so depending on where you are, I can assign people that are probably closer to your language and your time zone, and be delighted to work together. Thanks again, Tobias, for inviting me to join.
No, thank you for an awesome demo talk presentation. It had everything you could want in a tech talk. So it was a good way to kick off after our short little Easter break, and really appreciate all the effort that's gone in, the time and effort that's gone in, and resource that's gone in on your side and on Alep's side to make this happen. So thank you to you both and all the teams involved from all partners to get this and make today happen. All of today's content will be available on demand immediately on the live stream on YouTube, and we'll edit it a bit just to make it a bit easier to watch by this time tomorrow. If you want to sign up for any of our upcoming talks, just head to arm.com/tech talks. We've got some really exciting topics coming up that are already live, and a lot more in the pipeline that we can't yet talk about, but will soon be live. So make sure you keep revisiting that page and join us for our future talks. Jeff, thank you so much again for a great presentation. Audience, thank you so much for your great questions. And I look forward to seeing you again at next week's talk from Renaissance and at 4 p.m. UK, 8 a.m. Pacific, where once again, we'll hear about the latest in trends, technologies, and best practices from Arm and our ecosystem partners. Jeff, thank you so much again.